right, welcome to the third session of today, Building Agility in Manufacturing Industry, with unique perspective from the end user, consulting, educator, as well as solution provider. I'd like to welcome to the stage David Arians, the moderator for this session.
Thank you. Also, welcome from my side. First of all, we love to hear where you're from, so drop a line in the chat. If you have questions, make sure to post them in the Q&A. And we'll make sure we are on time. So this session will run for 1 hour, and let's dive into the topic right away. So today we'll be talking about thriving amidst uncertainty and building agility in the manufacturing industry. And to do so, I'm joined by Katie Armstrong. She's a co-founder at Armstrong Lin Optimal Solutions. Dave Evans, co-founder and CEO at Fictive. And Francisco Almado Lobo, CEO at Critical Manufacturing. And myself, I'm David Arians. I'm the co-founder and the author at the IIoT Insider, which is a blog, podcast, and online academy helping you to bridge the organizational and technological IIoT gap. So, Katie, can you quickly introduce yourself to our audience?
Yes, hi, thanks so much for having me today. I am the co-founder of Armstrong Lin Optimal Solutions, which is my consulting company. Myself and my business partner specialize in helping small companies, startups, and mid-sized companies grow their operations. I'm kind of on the operations side. My background is in supply chain as well as production engineering in advanced manufacturing, so semiconductor, automotive, chemical synthesis, all of those great things. And together we can help our clients come up with unique solutions in both operations and finance.
And we'll talk about those things in this webinar. Thank you, Katie. And hi, Dave. So same question for you. Who are you, and maybe where are you calling from?
Well, how long do you have for who I am? That could be a long one. But,
so let's go for the elevator pitch version.
Okay, we'll go for the elevator pitch. So I'm Dave Evans, co-founder and CEO of Fictive. I'm a mechanical engineer by background. Started my career in automotive at Ford, building infotainment systems and dashboards of cars. Founded Fictive 12 years ago now. We are a global manufacturing and supply chain company, helping to simplify sourcing for custom manufactured goods. So think about a lot of mechanicals. We build everything from satellites to electric vehicles, to clean energy storage systems, to nuclear power plants. So really excited to talk about the building agility in manufacturing and give you the lens from a Silicon Valley company that's built a lot of AI over the last decade. So thanks for having me, David.
Yeah, that's actually a really, really wide span of, I would say, type of activity. So let's dive into that later in this conversation.
I said, how long do you have? So, but I give you the short one. But yeah, excited to dive in. So thank you.
Cool. And then finally, of course, Francisco. So same question for you, Francisco.
Yeah, thank you. So thank you again for the invitation. My name is Francisco Almada Lobo. I am co-founder and CEO at Critical Manufacturing. After working in the semiconductor industry for over a decade, I have co-founded Critical, and we're a software provider of what we call Industry 4.0 solutions, being manufacturing execution systems, our most well-known product. And they provide that to different manufacturing industries, quite sophisticated ones, including semiconductor, electronics, medical devices, industrial equipment. The company's headquarters are in Portugal. I'm Portuguese, I'm from Porto, but I'm doing this out of China today, just to prove that this is not, recorded, because we have operations across many different countries, Germany, US, Mexico, Malaysia, and China as well. And now I'm here in Shenzhen. So what else? Beyond my work with Critical Manufacturing, I'm quite active across a number of other areas, but lately mostly around the venture capital world. When I'm part of several investment committees, I'm an advisory board member to different startups, and beyond being, of course, myself an angel investor. So this is one of the activities that I enjoy the most. I'm not sure if you're going to talk about that, but just to let you know that.
Yeah, maybe for our next one. So this is truly a global webinar. So I'm based in Europe. We have the US, we have China. So interesting stuff. So this is a session about agile in a I would say an environment many believe is quite the opposite. Francesco, you were the last one, so I'm gonna stay with you for a while. What is agile, and more specifically, what is agile in manufacturing?
Yeah, thank you for that question. So agile is a very well-known term in the software industry, and although some of the principles are similar, it has a slightly different meaning within the manufacturing space. So manufacturing being agile is not just about speed or flexibility, but it's about, I think, in my view, the ability to respond rapidly and intelligently to change. Whether these are, sudden shifts in customer demand, supply chain disruptions, unexpected production issues, and all of that. So while, again, agility draws inspiration from the agile software principles like adaptability, iterative improvements, cross-functional collaboration, but it also builds on the foundations of lean thinking, which focuses more around efficiency and waste elimination. And together they shape a manufacturing approach that is not only optimized, but also resilient and responsive. So in practice, it means for us, a rapid reconfiguration of production lines. It means fast optimization in response to constraints or opportunities, the ability to, seize really short-term market windows that might exist, and also, again, resilience on the face of external shocks. And we had a few of those over the last years to prove that this is really needed. Yeah? Just a few over the past 4 months.
Just a few, Francisco. Casual.
I would say it's a stress test right now.
Correct.
But it's funny because you mentioned lean. I would say lean definitely stems from the manufacturing world already quite some years ago, which then turned into agile. Agile got more adopted by the IT world. I think it's time to bring it back into the manufacturing world.
I fully agree. And I mean, we're trying to do that. Sometimes it's a little bit difficult, even when projects that we do with manufacturing world. There's a lot of people still in the industry which still have a very conservative mindset. It's not easy, but I think agile principles are definitely needed within the manufacturing operations, but also in software projects for manufacturing. Absolutely.
Katie, over to you. Yes, there are quite some disruptions today in the world. So I just want to link that back more specifically to supply chain challenges we're facing, because manufacturing is obviously more than just creating a physical asset in a plant. There is this entire supply chain around it. How can companies strengthen their supply chain, in your opinion?
Yeah, great question. So I think Agile is actually something that can be really useful for strengthening a supply chain. And the reason that that's important is because, like you said, there's so many disruptions now, right? It's a very sudden disruptions between geopolitical tensions. COVID was obviously a huge one, right? Like plants shutting down. And now even climate change is becoming a huge risk. We had, I think it was 2021, we had the big freeze over in Texas, which forced a lot of manufacturing plants to just shut down completely, which is a huge supply chain issue, right? And so I think being able to move quickly around those challenges is super important with supply chain, but it's also something that can be really, really challenging with manufacturing, especially advanced manufacturing. Industries like semiconductor and automotive, it can take over a year to get more suppliers qualified if something is already kind of set in its design. And so I think these turbulent times, to be honest, have kind of forced OEMs to be a bit more flexible on that, just out of pure necessity. But the most important thing that an OEM is going to be looking for when qualifying different suppliers or managing risk and getting more sourcing, dual sourcing, is they need the data. So they need to know that you've qualified your supplier, that you've tested it in your process, and that it's not going to cause any unexpected issues. And having the data, I think, is something that is the most challenging thing for manufacturing. And that's kind of what we're talking about now today. But having that data infrastructure there and having actually the data available is actually going to really, really help you be able to move in a more agile way with your supply chain.
I think there's something really critical I can just double down there It's one, yes, do you have access to the data? But then two, are you making decisions? Is the data actually actionable? So as you think about lean moving to agile, it's really the ability to execute on some initiative with a set of real-time information. And so for so long, we've been saying, great, we're going to take information and store it in a large 3-letter acronym. MPSs, ERPs, my product data lives in a PLM. And really, I mean, Katie will probably attest to it, a lot of it lives in spreadsheets.
Yeah.
That system gets exported, put into a big Excel, bunch of macros, but then that doesn't become agile anymore. So you've done analysis on it, but you're not actually able to move. And so in this world, I know we'll talk about connectivity, I know we'll talk about creating the data to be able to execute. But I think it's so critical, just to double down what Katie said, is how do you actually make information available to then be able to execute on it?
Yeah, and to make it even more complex, I would say when we talk about data, we typically look to our own manufacturing process, our own set of data. But especially, Katie, when you're talking about your supply chain, integrating data from different parties in that supply chain, that's even a bigger problem today. At least from my point of view. I don't know how you see that.
Yeah, I mean, I'm happy. Go ahead, Katie, please, and I'm happy to give some examples if you want.
Oh no, I was just agreeing. It's definitely an issue, yeah.
So in our world, we run a global supply chain and manufacturing business, but it's all connected. So I don't own any factories, I don't own any machines. We have about 250 suppliers, we call them manufacturing partners, that are pre-vetted, connected with our technology in 4 different countries: China, India, Mexico, and the US. So what happens is an OEM can come in and plug in directly to this Fortune 500 ready to go supply chain. But the difference is, and Katie's probably stood up a bunch of these from DuPont to other areas, is every company's trying to set up what seems like a bespoke supply chain, but actually they're more similar than different. And so what happened then is we looked at the events from the last 5 years. So you can take a COVID, you can then take a force majeure like the freeze over in Texas, Suez Canal, Baltimore Bridge gets run into, all the way to geopolitical tensions and tariffs being at all-time highs. All of these are events that happen, and how are you plugging that in to move your supply chain around in an agile fashion? David, to give you an example. Or for what you're talking about. In our world, we focus on custom mechanicals. So we're making the plastics and metals in a BOM, and a bill of material for satellites, surgical robots, EVs, you name it. Those types of commodities. And so to give the audience a real example here, in 2020, we had this little thing called COVID, and in January in Shenzhen, where Francisco is, and then more in the April timeframe for the US, we had full shutdowns. And so for us, when we had a shutdown that hit our China region first, we pulled out what we called our disaster recovery plan. And we had 261 active purchase orders, so work orders that were being produced by factories in the Guangzhou area. So, in the southeastern part of China. We were able to take all of those and move them outside of that region affected with no hit to lead time, and only like 5 exceptions where we couldn't move that work. And we did it in 24 hours. 24 hours, because it's all digital systems. It was already connected, and you had a supply chain that was done. And so then you take the same system, we can talk about it today, and we matured that over the last 5 years as Suez Canal happened, and I have trade routes or shipping routes that I can't do. As we had, shutdown from force majeure, natural disasters that have happened, all the way to, we have a product today that allows you to build an injection molding tool, and you can produce that tool, move it around to any country in the world. That's on our region. So we have four regions that are stood up. So typically when you have these big tools, that make instrument panels for, say, cars, once when you pick a factory in China, you're stuck there. You can't do anything. But what we built and engineered is the ability to move that from, say, China, then you onshore it to the US. US, you have labor issues, you push it down to Mexico, so it's nearshored. And you can even move that thing to India if you're worried about the tariffs that are on your plastics. That is agile manufacturing, just to give the audience a real example here. But I couldn't agree more with Katie that you need data, you need it connected into systems, and if you do that, you can make some really awesome choices.
And I'm gonna plug in a question from the audience right away because it's actually it fits perfectly. Olga asks, in manufacturing, mistakes are costly, but agile encourages learning through failure. Now that's an interesting paradigm because it's also a bit like old school versus new school type of manufacturing here. So maybe I don't know who wants to take that question, but so how do we balance? I would say the cost of mistakes, but still learning through doing. Maybe Francisco?
Yeah, I can go there. So I don't think it is through failing. I think it's through a little bit like in the software agile, is small iterations and trying to correct upon these small iterations. And the end game is that despite these iterations, which can still need, they may still need adjustments left and right, at the end you get to a faster and to a better result instead of not using an agile type of methodology. So this is basically what's about. So it's not. I don't agree that it's really through failure. Because yes, it's correct in manufacturing. You mean, first of all, manufacturing has failures. Okay, just in case you don't know, there's a lot of manufacturing. Manufacturing failures can be more. Can have a higher cost or a lower cost depending on what type of failures we're talking about. But the thing is, we need to understand that we need to put the mechanisms in place so that you can monitor, so that you can track, so that you can adapt, so that whatever failures remain in-house, remain controlled, and then we can adapt faster. That's the how I would respond to that.
Yeah,
Go for it, Katie.
I was going to say, I can add to this as well. I think a big difference between the software industry and manufacturing is that manufacturing has a very robust culture of risk analysis. And so I think that can kind of protect you from those failures a bit. And that's something that manufacturers, I think, struggle with, because I know in my career, I've seen that people are just afraid to make change in general. And so they just will not try. But then that can lead to big disasters like a supply chain meltdown or a huge customer issue, and you're losing millions of dollars. You might get sued. That happens in the semiconductor industry all the time, And so that's, I would say, a much larger risk that isn't always being addressed when you have these leaders that don't want to make any change. But if you can come up with a kind of a robust risk analysis process, and which means you have to have a really good understanding of your manufacturing process, of your suppliers, of your customer needs, again, coming back to that need for the data and available data, then you can kind of overcome some of the challenges of failure, because if you have looked at the risk and you understand the failure modes, then you will come up with an acceptable level of risk where if something does fail, you're probably going to know why it failed, what it was, and how to kind of combat and contain that failure. Because containment, all of that quality, all of the quality things, that's something that's a lot more prevalent in the manufacturing industry. So that can protect you a bit from that as well.
Yeah. One of my favorite photos, I just put it in the chat here, is the entire SpaceX team celebrating when the rocket blew up.
Yeah.
And they've become known for this. And so as an engineer, everything you're trying to do as an engineer is find the limit of whatever the thing you're creating is. And you typically never find that limit until it breaks. We do FMEAs all the time, failure modes and effects analysis, and we try to figure out and run the analysis that Katie's talking about. But can you build a culture that when your rocket blows up on global, national, whatever television, your whole company cheers? You want to talk about culture? That's what we should all strive for. Not that, I'm a line down. When I was at Ford, if we were lying down and the factory wasn't producing cars, was the team cheering? That was a bad day. But when the rocket blows up a $100 million vehicle and you have your whole company cheering, you've embraced agile. You've embraced this ability where the learnings from failure trump the celebrations of successes. And that's an important part of agile.
And that also, it's also another way of working or another way of producing, because one of the things which allows SpaceX or other companies to do what they do is to be very modular and to be very data driven. So they allow specific teams to optimize a specific part of the, in that case, rocket or car or whatever the example is. They allow specific teams to optimize a specific module. But they also, and that's I think really important, is they also have a very good understanding on the dependencies this module has on the, I would say, the other parts of the, in this case, the rockets. And this way of thinking, that's also it's also a mind shift for the traditional manufacturing companies.
Yeah, I couldn't agree more. And so I think that you talked about how, Agile came from lean, or started with lean, moved to Agile, IT, world developed Agile. We shouldn't think that just because it came from lean, manufacturing knows how to do this well. The software world has developed and really matured the Agile methodology for the way that software product is developed, far beyond, a TPS, a Toyota production system, in a lot of ways. And if you look at the fastest growing industries, it's technology. So the question should really be, how do we take the advancements of Agile in software product development and apply that to a physical or hardware product development? And if you can take the principles where they do overlap, and I think, David, what you're talking about is individual subsystems, then what are you actually testing for? That's gonna help you really win ultimately. I think my point I'm trying to drive home is it's actually around the culture. That's why I love that photo. Is we talk a lot about this concept of Agile and that we want data and connected systems, but when it comes down to manufacturing is run by people.
Yeah,
run by people. And so it's like, we can talk about all the technology. I'm a Silicon Valley company. We've raised hundreds of millions of dollars. I have hundreds of employees in multiple countries, but it's people. And so can you build a culture around Agile thinking, celebrating failures? And can you do that at a global scale, which is what's needed for manufacturing truly to develop this type of Agile methodology, so that when the rocket blows up, you succeed. So to all the listeners that are here, think about the organizations that you run, whether you come from an IT background or you're running, semiconductor or chemical power plants like Katie's talking about. And for the leaders in the room listening, what can you do to build the culture around agility? And if you do that, I think that the industry as a whole will embrace this type of methodology.
No, that's I would say thanks for this first Q&A we've answered. I'm going to try to plug in a few more during our discussion. Dave, I'm going to stay with you here for another question. So you said it's a people business, absolutely. But how can digital tools today help us in I would say in being more resilient, in being more agile, in dealing with disruptions?
Yeah, I think that, like we've seen in the IT and technology sector, the more that we can connect all these discrete decision making that happens in any organization into a centralized database, the more agile or the better decisions you can make. Then you put AI on top of this that can actually help augment a lot of our own biases or the ability to make decisions. That's where great things happen. Yeah. So if you talk about specific examples, let's take a customer that we work with. We work with we'll talk about a commercial satellite company. So we work with a company that's based out of Texas, since we're talking about Texas, Katie. And they're a public company, raised over $1 billion, and they make a communication satellite that Verizon and AT&T use to connect all their cellular networks together. They could say that in a traditional way, David, they could build a supply chain that is based upon a lot of how the primes build it. So whether that's a Lockheed or a Boeing or anyone else that's building, kind of commercial satellites. What they decided to do differently is ask the question of, is there already a supply chain that's set up? And how is the performance of that supply chain that already runs? So rather than build it, I can plug into it And can I get my costs actually reduced, as well as reducing my risk of just building a supply chain that's near the factory in Texas? And so in this specific example, you're asking about how does data, help drive this? They used all the data of the performance of our supply chain over a decade to say, do I have reduced risk, and can I decrease my costs in order to hit my business milestones of all these launch dates? Satellites are really hard because you have a cross my heart, hope to die date that the rocket is launching, and that vehicle must be ready at that time. There's no margin of error. You can't wait to the next launch. It just doesn't work at all. And so that's, I think, an example where a commercial satellite company is leveraging data, looking at historical performance to inform decisions around risk, as well as inform decisions around cost, to build, a pretty complex supply chain. And, the net results were saving, seven figures, millions of dollars every year in their supply chain. So PPV, purchase price variance, dropping that while reducing risk as well. And so those are real results from real companies, for the benefits of connected data systems.
So it's itching to become a little bit more technical. I don't know why, but I always have this thing. So maybe Francisco, back to you. I wanna start because we talked about the importance of data. I think we all understand that. Some great examples all of you shared. But I want to go back to basis, and I want to start with the challenge of tackling machine connectivity, because we've been talking about Industry 4.0 now for, I don't know, 10, 15 years. I don't think we're quite there yet.
No, you're right. We're not. And it's what's quite interesting, because I was listening to Dave and Katie talking about the data coming from the supply chain, and I'm a manufacturing guy. And so, below the supply chain, there's manufacturing. That's where the data comes from, right? And so, it's really a challenge. It sounds easy when Dave says we're connected to different suppliers and we just switch one supplier for the other and so on. But then I know the reality inside manufacturing, right? And the reality inside manufacturing is that you have, lots of different machines. The machines come from different vendors. Most of the factories are brownfields, and so they have different generations of the same type of machines. Many of these machines, they have different communication protocols. Some of them, they even have the machines without the protocols or without the right versions, or it's a zoo out there. Okay.
And with no Wi-Fi, how many factories in Cisco have you been in?
There's no Wi-Fi. Right, absolutely. There's no Wi-Fi whatsoever. So this is really a zoo, and so this very heterogeneous environment poses really a significant challenge. So how can we achieve seamless connectivity and have a kind of a unified way of collecting data, which is what we need. So there's a lot of topics here. I'm not talking about now the retrofitting, which is a topic by itself, about how to provide back sensors, custom sensors, so that you can start having data coming out. But right now, my main concern is that in the majority of these manufacturing environments where I work a lot, there's all these different types of protocols and so on. And many manufacturers are turning into things like protocol converters, or there's lots of companies talking about industrial middleware, like for instance OPC UA servers, so that's the connectivity to the upper side, to the layers above, are done in a more consistent way. There's, and I want to get too technical, but there's MQTT brokers, there's IoT gateways, there's all sorts of things, so that the data is unified, so that we can bridge the communication gap between disparate systems. And so this is one very important thing. And so we need to have architectures, and that's where my main experience comes from, that kind of detaches, of course, the communication, or splits something that happens at the edge, where we are having data being connected, and then we split the edge from the server side functionality. And first of all, we need to something also very important that was said today, regarding data, and having data which is actionable and data which is sufficiently rich, so that decisions can be made. And it's important to talk about the context of data, contextualization of data. Because when we connect to different machines, connecting it and getting the data out from sensors is, of course, the first challenge. But the second one is to try to give a little bit more context, because if you connect to a temperature sensor, the only thing you're going to have is readings of temperatures.
Yeah.
Right. And so you need to put a lot of additional context in place. And that's why we provide MES systems together with the connectivity, so that the MES system, a manufacturing execution system, is a great contextual layer of information to enrich this data, to enrich these data sets, to normalize this data, so that later on we can have the right data integrity, the right traceability, the right historical analysis that can be done, so that decisions can actually be done confidently. And so there's a lot of things here, but it starts again with the connectivity, the different type of protocols, how to harmonize that, how to separate the connectivity from the rest, how to do a first level of contextualization still at the edge, and how to contextualize it further, so that then using data in a kind of a data model that is usable can be done. And so it's much harder. What I want to say is that all of this is much harder than what it sounds at the first place, and especially supply chains are already a kind of an abstraction of all of this, because we're talking about much higher level stuff, and that we need to start by connecting and integrating the basics.
Couldn't agree more, and I think context is indeed the thing which links readings to the physical reality where we're operating in. This is a perfect time, Francisco, to launch a poll we've prepared. I do hope, here it is. So we have a question for the audience. Which of the following manufacturing software capabilities do you currently have in place? I think there is, or you can only select one. So select your most important one. Do you have stuff at the edge? Do you have a manufacturing execution system in place? Or do you have a fully integrated IoT or OT data platform in place? And we give you a couple of seconds. Once we have that answer, we'll launch a second follow-up question as well. So I hope we can now launch the follow-up. The follow-up is from these three. Yes, so Edge, MES, and really a platform, integrated platform. What describes your current setup? So you have nothing. You have maybe one or two, all three, but not fully connected or integrated, or all three. And it's like the holy grail of data connectivity. It's fully integrated and perfectly working together. And then, alrighty. So, yeah, I have the answers. Thank you for that. So the technology is working. Amazing. Alrighty. So I see 16% on the first question. 16% is on the edge. 50% is has a manufacturing system in place, an MES system in place, and 30% has a data platform in place. So that's significant, I would say. 50% with an MES. Katie, well, what do you typically see?
So it's funny. I saw a comment come through that it said most of my small customers have nothing listed, only machine data and Excel. And I would say that's more the world that I live in, especially where I typically work with smaller companies in the consulting world, and so that's kind of what I'm more used to seeing. But the prevalence of MES is definitely growing, and I think one of the things that I kind of do is help clients understand the value of it, because I do think that a lot of companies operate based off of Excel and machine data for too long, when their operations are kind of past being able to manage it that way. And then you have, manufacturing engineers where their entire day is just spent manipulating data, trying to make the data usable and understandable. And I think when you get to that point, you have to really start looking at, okay, what's the cost of the system versus the cost of this person doing this all day? And I think a lot of people struggle with that. And with a lot of manufacturing companies being, not the most data literate, I think it can also be a very intimidating change to input a big system like that. And so I think, companies like Dave and Francisco, where they can come in and kind of make it easy for you and provide a user-friendly solution is really critical. But I would say I've definitely seen more the Excel plus manual data side at companies that are way too big to be using that.
Yeah, I assume then I would say our audience will probably be a bit more the bigger companies in this webinar. Now, having said that, I like your typical. I also come from a bigger one. I'm come from I would say my background is in the chemical industry, but what I do see is that your typical MES project is a bit like your typical ERP, or used to be a bit like your typical ERP project, like really, really big waterfall style projects where you're implementing like this huge scope, and that has the tendency to fail, unfortunately, or at least be extremely costly and run over budget. So I also think that
it's about time we change that perspective.
I see that there is the poll is again launched, so I'm sorry for that. Do it later. No, here's the answer. Yeah. Thank you for the nice answer. Let's change that perspective. Maybe, I don't know, Dave, if you want to jump in here.
Yeah, I mean, I think continuing to build off of it, the whole conversation is, how are you collecting data? That's all the edge, related. How are you storing it to make actionable related things? That's the MES, or pick another 3-letter acronym on there. And then, do you have a data lake to be able to put AI on top to make decisions? Like, if I just had to dumb it down in layman's terms, it's like, how do you collect the data? How do you store the data? How do you make the data actionable? And a lot of what we're talking about in the smaller businesses that Katie's saying is, well, the way they collect the data is they walk the shop floor. The way they store the data is in Excel. And then the way that they make it actionable is they sit around in a meeting room on a whiteboard and make some decisions on there. And I think, David, what you're talking about is, okay, well, the audience has larger, more sophisticated, a Honeywell-sized business. And so you're like, well, of course, Honeywell, Siemens, Schlumberger, Schneider, they're going to have these big MESs that are all connected. Well, actually, they've acquired a whole bunch of small businesses, like what Katie's talking about. And then the big conglomerates are spending a lot of time trying to actually integrate this into, grab the data, make it centralized, and then make decision making off of it. So I would just argue, or what I'm trying to add, is that even your large Fortune 100s are really just a culmination of a bunch of SMB and mid-market companies or factories here. And so what's really important that we talk about is, how are you going to put the best-in-class technology into the system to leverage AI to actually be able to make smarter decisions? Because I think all these questions are great that's on the screen here, but the IT world has kind of moved on from this into AI. Edge isn't really what we're talking about in Silicon Valley. That's where I'm based out of. And so I would just, I think it is good to talk about a small business versus large enterprises, but I think it's a manufacturing ecosystem as a whole. We have to think about these three systems.
Yeah, let's. I wanna show one slide here. If the IIoT World team can show the picture we prepared, Francisco. So this is the perfect time, I guess, to talk about the holy trinity of connect, execute, and analyze, because Yeah, sure. Maybe we could now go into a 3-year during MES project, and then, but that's probably not what we want to do, right?
Yeah, no, absolutely. So, but let me go a little bit back by giving some context to those results. I'm really a bit surprised with the results, although they were changing dynamically while you were looking at them.
Yeah.
But there's a few things there. One is that MES was much higher than what I was expecting. Really much higher, because you asked what is the main thing,
Mhm.
and the majority actually mentioned MES. So I think the first point is that many people have a different understanding of what an MES is. An MES can be kind of a broad category depending on what to talk about. There's a comment here from Kevin that says, so many businesses think MES means many Excel spreadsheets. Right? So
Well,
we
it's
need to.
not. It's not, Francisco.
It's it's a little bit more than that. But again, so I think it's interesting, but it might mean many different things. The other thing I was very surprised is that typically when we talk about an IoT data platform, of course we can talk about a data platform that collects information from many different sources, but in the majority of the cases, the main source is actually IoT data. It's actually data that comes from the equipment side. And so I cannot really interpret very well how come we have only when I looked at it, 16% saying that IoT or edge connectivity was what they had, but then more than double had data platforms in place. Okay, so I found it's really interesting. It's the way people interpret this kind of questions. But back to this, yes. So I coined the term Holy Trinity here for this, and maybe I'll put some trademark behind it, so, so that I receive something when people start talking about it. But I want to talk about this in context of what they were saying, because you mentioned this is just the basic things, and everyone is pivoting towards AI, and I couldn't agree more. But this is the basics. So if you don't have the right things in place, if you don't have the right context, if you don't have the right information, there's no AI for manufacturers to actually do anything. And so we put together this framework, and this is a framework. Okay, so there's no commercial things here. It really depends on how it can be. You can have different vendors having different solutions in this area. But on one side we have the connectivity, which is the first block on the left bottom. We have and so the connectivity is where it all starts, right? When you have it's a foundational for the real-time visibility. This is the one that actually translates different machine languages into a common communication layer to enable real-time insights. Then you have MES, and MES is a very important execution layer, because this is where we coordinate production orders, we track materials, we track processes, ensure the right level of compliance. And yes, it still fails a lot, like the ERP projects fail, right? It's not just something that happens with the MES, but there's a little bit more variation, a little bit more uncertainty, a little bit more specializations of processes, which make it harder to succeed in the MES space. But so MES not only does that, but ensures the right level of traceability, enforces the SOPs, the standard operating procedures, and optimizes production efficiency. And then the third pillar, which I put there as a data platform, they've referred to it as data lake. So this is solutions that ingest data, store data, and transforms the data for whatever advanced analytics we want to do, being it AI from the classical machine learning models to things which are a little bit more sophisticated, the usage of Gen AI, or today the AI agents that everyone's talking about. So it really needs this consistent data set. But I think the issue is that it's not only just about three things, but this is how the three things combine together. So when you have a combination of connectivity and MES, you can start having contextual information. You can start having interlocking mechanism between the two. And when this connects to the data platform, you can have data which is sufficiently contextualized. And very importantly, you can have a pre-built data model. because the MES is almost like, I don't know how to say it the right way, but it's almost like the basis of a digital twin, the framework or the skeleton of a digital twin of the manufacturing, which then you can plug in data, the real-time data that comes from different equipment. And so this becomes the basis for analysis later on. So when we have data science teams, they only work with data sets. And so if we cannot provide them the right level of data, clean data, with the right level of information, the right context, and so on, they're going to spend the majority of their time just collecting data, cleaning data, trying to do things, and not really, putting their efforts where it matters the most, which is to find the right patterns and find the right, insights that they want to build. And so I think this is what I try to explain. When you have the merge of the three, we also say this is where magic happens. Right, and again, it can be with the products from Critical, it can be with any other product, but it's the combination of these three that makes this really happen.
And Katie, your perspective, what is needed from let's say your background, maybe also the small manufacturer background to achieve this?
Yeah, good question. So I think kind of one thing that Francisco said that stood out to me is that you can't really have AI solutions if you don't have the data. And so I think kind of from my perspective, the most important thing is actually collecting the data, gathering the data. And so that can mean, inputting actual hardware to sense data from the manufacturing processes, like the temperature sensors. And there are, I know, actually some AI companies coming up now that are working on data collection as well. So putting a device on the manufacturing line itself and collecting data that way and then analyzing it. So I think that there's definitely some unique solutions out there as well. But I think from my perspective, the IT world, the software world is advancing so quickly, like Dave was talking about, and manufacturing industry is still kind of over here a little bit behind. And so I think the most important thing right now is to be able to get the manufacturing industry just to a place where they can collect all of the data that they need to then go on and do this analysis. And that's a lot of education for manufacturing workforces, right? These are people that have not worked really with software before. So the workforce itself needs to be educated, and the value of these systems kind of needs to be communicated well, and the integration needs to be made easy. And that's something that, it's a lot of culture work, to bring back what Dave has talked about too, right? Like you have to work somewhere that has a culture of using your employee ideas for improvements and understanding where people are, and not just saying, okay, we're going to use this new system now, figure it out. Like understand that people are not going to be used to this, and they're going to need some sort of upskilling and education to make that change happen. And making sure you kind of acknowledge that as leadership in manufacturing, I think is, from my perspective, from what I've seen in my career, that's the key thing.
And you now also more or less answered one of the Q&A questions. One James posted was a recommended approach for upskilling training. We are almost, I would say, we're nearing the end of our discussion. So if you have questions, start posting them right now. Dave, want to get, I would say, a bit to the Silicon Valley view on upskilling training, especially when I would say we're talking now on all the co-pilots and agents which are flooding our, at least my LinkedIn feed. So what's your perspective on how do we make sure that we keep up with these trends and we upskill people and we make sure that we don't leave them behind?
Yeah, I mean, I think that enablement, training, workforce development has been an ongoing theme in manufacturing for decades, probably forever, probably before I was ever born. We're always talking about how do you train the next, because the reason is, a lot of manufacturing is based upon prior knowledge or this like decades of history that you've worked an assembly line. Francisco talks about a machine that's, very old or not connected. And so what I would argue from the tech perspective, being the Silicon Valley guy in the room, we can actually leverage all of this data, which is really just a set of decisions that have been made. That's mostly what it is in these MESs, that we've made this decision, we've seen this outcome, to help train and enable people faster. So let's get granular. That if I have a new operator that comes in, like Francisco's talking about, that's running some piece of equipment in this factory, maybe they've used that piece of equipment in another factory before. But if you're going to train them, you kind of sit them down, you put them in a PowerPoint, here's how we run, here's the shifts, here's what's done. If you could actually train that individual on how is machine 7 operated, and when is it down, and when you run it at this temperature, pressure, force, whatever it is, this is where it might fail. Mm-hmm. Like at that granular level, if you can actually use actionable data that pulls, from this holy trinity that Francisco talked about, to make better decisions, that's great. In our world of running, global supply chains, if we have these orchestrators that sit there that help basically push things globally. We're basically running this in a co-pilot way today. So we believe that the best type of automation is autonomation. So this concept comes from TPS, Toyota Production System, where you have human plus machine. So automation's goal is not to have 100% lights out automation where the machine does everything, but where you basically automate up to 80, 90%, and you let the human do the last 10% of the task. And so the best type, this has been written about a lot in Lean or in Six Sigma practices, is that the best type of automation isn't trying to spend 90% of your effort perfecting that last 10%. Mm-hmm. It's actually you get it up to the 80 to 90%, and then you take really skilled operators and you have them, complete the final task. And so we've embraced this to the core, whether it's around, manufacturing engineering, whether it's in this orchestration, any of these places where we've built really hardcore technology to automate. We've then up-leveled or take skilled workers that have run global supply chains and said, okay, great, we're going to train you to do the last 10%. And so in your old job, maybe you did this full set of, tasks that's 100%, but in our world, the tech is going to do 90 and you're going to sit here and do exception management.
Yeah.
And so, as we think about the training, workforce enablement, just to answer your question, I would push a lot of the folks here to think about, can you put automation in place that takes 90% of the mundane tasks out of that workforce? And then can you train them on exception management? And if you can train them on the exception management, you're going to build a really robust system that truly is agile. And that's based upon a lot of this data. And you'll have a more engaged workforce that's excited every day because and that helps with retention.
Any other insights to add to this question before we jump to the next one? No. Then gonna pick the one Peter just submitted, and he says he asks, so how and where do you start implementing connectivity in manufacturing? Because it can be very hard. And this is the interesting part of the question. It can be very hard to justify the effort. So now we come to the ROI question, and I would say the difference between investing in foundational stuff versus investing in visible output. Who wants to take this one?
I want to take this one. I'm not sure if you can hear me or see me because I don't have a camera anymore, but I hope that my connection is still.
We can still see you, Francisco. So you're all good.
Okay, very good, excellent. Yeah, so you really hit the nail. This is a foundational technology, and so what I typically say when people ask me for ROI of connectivity or ROI of MES, what I ask them back is, well, who did the ROI for your ERP? Right, and in the majority of the cases, there is no ROI for ERP. Yeah. This is a real need. Why? Because it's a foundational aspect that then enables many different things. So the same happens here. When we're talking about these three elements that we're talking about today here, these are foundational elements. It not only is possible to derive future use cases where you can have very solid ROI, but you need to think about the ROI of all the cases that you need in the future, that you may have in the future. But also, you need to ask yourselves if you can be even in the manufacturing segment without this going forward. It's important. Again, it's important to have really ROI justifications. But when you're talking about the foundational elements of the infrastructure elements, they need to be in place. If they're not in place, if these type of frameworks or platforms are not in place, it is, it will be very, very difficult to in the future, even be in the space in the manufacturing world. That's at least my view.
Katie, Dave?
Yeah, I can kind of add to this. I was just going to say this is actually kind of where your finance team can be your friend. And so I know, because I'm an operations person and my business partner is a finance person, those departments usually don't enjoy each other. They don't tend to work together. They tend to butt heads a bit. But actually, in this case, this is where you can, as an operations person, go into your finance team and really tell them all of the manual work that's happening.
Mm.
And then like this, because I did this with my own business partner, right? They often don't really know what's going on in operations. Like they have some number in their head for overhead, but they don't actually know what's going into that. And so this is where you can actually, if you can befriend the finance team, right, you can kind of get them on your side, because you can explain how much faster things are going to be, but then also have them look at cost of poor quality, because this is something that's really, really hard for finance teams to calculate if they don't have that operations insight. And so if you can kind of go in and explain, okay, this is everything that goes into a quality excursion, like engineer time, loss of customer trust, anything associated with RMAs, then you can really start getting into the nitty gritty of a justification, because we know, and I know, I'm sure the person asking the question knows that it can be a real battle to get leaders on board with spending money on something like this.
Mm.
So I would say, in addition to everything that Francisco said, because that's absolutely correct, like this is a functionality, it's not, something added. But in addition to that, if you're trying to change the mind of leadership, get your finance team on board.
I absolutely, I love the answer, and it's not us versus them. It should be everybody, I would say, on the same page. With that, I would like to thank all of you for the great discussion we had. I really enjoyed it. I also like to thank the audience for all the questions you submitted, and also the interactions we had on the chat. Made it a very, very fun session to host. I would like to ask you to rate this session, to give us some feedback, so we know what to do better next time. I'm gonna thank our sponsor, Critical Manufacturing, one more time. And I'd love to invite you to join the next session, which will be the Edge to Cloud synchronization session with case studies from John Deere, Influx Data, and Snowflake. Thank you very much for joining in. Thank you to my panel for the lively discussion, and until we meet again. Thank you very much. Take care. Bye-bye.
Thank you.
Thanks, Mark.
Nice to see everyone.